This is the fourth lecture in chapter 19, so we're going to start off here with the greenhouse effect. And you can just kind of follow through there and just take a look at our little numbers up here. So coming in, we have solar energy comes in, and a lot of it just bounces off as infrared radiation, and it bounces right back out, and some of it leaves and some of it gets trapped inside, hitting some clouds or whatever particulates might be in the atmosphere, and are held in and become greenhouse gases. And that's typically a good thing. It keeps the planet at a nice comfortable temperature. It's not cold. But if you start putting more and more of these greenhouse type gases out there, it might get a little uncomfortable, and it can change the climate in various locations and make things a little more extreme. That's actually the bigger deal in the whole mix. It's not necessarily that we're having change, it's the extremes that we're having. So this just takes a quick look at some of the different greenhouse gases that we have. As we mentioned earlier, water vapor is a greenhouse gas, and that's fine. We'll talk about how they relate to each other in a few minutes. Carbon dioxide, we all know that one. Methane and nitrous oxide, all those are present as well. And we've always had them up there, and again, they keep the planet nice and cozy. So this is the relationship of, one, how much we have up in the atmosphere, and how much of an effect it has on global warming, and lastly, how long they last for. All three are really, really important. Water vapor, clouds and such and stuff, of course, we don't see. It varies from place to place and based on the climate that you have. They have a relative effect of less than 1. Where does 1 come from? Relative to carbon dioxide. It just has a defined value of 1. And we can look at where we're at right now, 390. It has continuously been going up for the last several decades. But 390 is about where we're at now, and that really is a lot higher than we would like it to be. And it's not coming down anytime soon. Methane, comes from cows and such. It is 25 times the global warming gas than carbon dioxide is. That's not good. The good news is that we don't have a whole lot of it up there. But if we're really trying to control global warming, if we'd like to, we would really like to eliminate methane production. And of course, animals, cows, give off a whole bunch of that stuff. And there's other things too. We're actually trying to change our economy over to methane, so that's going to be interesting. But the nice thing is if we eliminated all methane output, 12 years later, most of it's gone. In comparison to carbon dioxide, this stuff can last for hundreds of years. So even if you stop, you're riding it out for quite a long time. Same with nitrous oxide. NO2, that stuff's going to be around a really long time, and even worse, it's 300 times more potent than carbon dioxide. And the worst of the bunch, which is why we no longer allow the use of them, is CFCs, chlorinated fluorocarbons. They are incredibly potent, and we'll talk about these guys later. So they have two problems with them. One is they're greenhouse gases. Luckily, they have a low concentration. And they last a really long time. But two is they are very, very potent in regards to being a greenhouse gas. So they're really, really bad. And again, they do some damage in the ozone too. So this is like one of the worst things we ever created. Anyways, let's move on. So what are some of the natural greenhouse gases that we have out there? Volcanic eruptions, these things pump them out all the time, continuously. Methane is completely natural. We have just escalated that with our use of cattle, and you can see the rest there. So, yeah, we've always had some of these greenhouse gases present, but we've kind of escalated this in more recent years with us pumping a lot more of these out there. These nitrogen compounds, we're using these from burning off fuels. Our agriculture uses an incredible amount of nitrogen. Deforestation practices, one, it eliminates our carbon sink, and it also pumps a lot more out into the atmosphere. Landfills produce some greenhouse gases, methane, and then CFCs. Again, we don't really use those anymore, but a lot of other industrial compounds are greenhouse gases as well. So this is the production where these come from. I know eventually you'll have a test question about this, so it's just something to kind of keep in mind. Where do we get methane from? Where do we get nitrous oxide from? And so on. So looking at these and how they have progressed over years, interestingly, carbon dioxide, that has gone exponential, as we can see. Methane seems to have leveled off, and I don't have a good explanation as to why. We use a lot of cattle, and cattle produce a lot of methane. But I would almost imagine, just guessing, that this will go up again as we really start taking on this fracking, because fracking is the mining for methane, and in the process of capturing it, they also lose a lot of it. So I would have to imagine that is actually going to start going up again. And the last one here, I can't see it on there. I have to move my screen over there. So I got to imagine that is nitrous oxide. Let's go with that. But I can't see it on there. So this just kind of goes into the idea of, what is humans' role in this process. So we see that, a lot of these numbers seem to be going up in regards to human activities. We've mentioned this quite a few times already. Same rule here, how are we seeing this? And I believe in the next slide or so, we'll take a look at some measurements that we've been taking and how we monitor it. We mentioned with the ice earlier. And something else that we do is we take a look at some temperature monitorings, just having stations all over the world just looking at numbers compared from year to year, seeing that world temperatures have been going up over the last 50, 100 some odd years. As we can see right on here. So, for obvious reasons, just because you like it warm outside doesn't necessarily say you should be embracing global warming. There's a lot of other effects that some we think we know and a lot that we don't know that may make the planet not as habitable in the future. But, there are some of these things that we do have to prepare for. Feedback loops. We'll talk about or look at these a little bit more on, I believe, the next slide. A positive feedback loop just means it keeps perpetuating, keeps going in the same direction. One matter makes it worse than the following. And negative seems to be a little more regulated. So we look at, as far as the CO2 cycle, for the most part, it seems to be a positive feedback loop. And positive does not necessarily mean good. Again, it just means that keeps going in the same direction with a little more energy. So this is what we can look at here as far as feedback loops. With the positive, again, if you have more CO2 in the atmosphere, that leads to higher temperatures, which leads to more evaporation and more CO2 leaving the water, which again perpetuates the problem, and then you get a cycle going. Another philosophy as far as a negative feedback loop means if you have more CO2 in the atmosphere, that means you're going to have more available to plants, and plants are going to grow, and as plants grow, they're going to store carbon dioxide, and that's going to regulate. So we kind of have a little bit of a conversation on both of those. Some other factors that are involved with climate change are these aerosols. And aerosols typically are things that absorb energy coming down from the sun and can prevent or cool the earth. Some of the effects of global warming. This is just this drawing is just okay. I was going to find something else, but I thought it worked good enough. But we can kind of see this was maybe once upon a time a extent of glacial ice, and we can see how it has shrunk in more of the white areas over time. The bigger issue as far as ocean levels, which we'll see, is this ice that is on land because it's not already in the mix. If it's in the water, it's not going to affect water levels quite so much. But if the ice is sitting on land, miles thick on land, you've pushed that off into the water level, it's going to make water levels go up even higher. So you can see how ocean levels or sea levels have changed over time. It has fluctuated quite a bit, so it's not like it's always been steady. And you can see right now we're pretty close to the highest it's ever been as far as the sea level 150,000 years ago. And I don't necessarily have a mark here as far as where we can start, but we can see that it has been going up at a fairly steady rate for, I would say, at least thousands of years. All right, this is a good place to stop. We'll pick up lecture number 5 in just a little bit.